All right, so this is a review for the similarity test, which you're taking on Friday. So if line L contains the points -4, 6, write the coordinates of A after a dilation with a scale factor of 2/3. So basically all you do is you take your scale factor and multiply it by each of the coordinates. So it'll be -4 times 2/3 and 6 times 2/3. And those will be my new coordinates. So this is 8/3, -8/3. And this one's 4. So my new coordinates, you want to write it as a coordinate point of A prime are -8/3, comma. All right, number 2, it says the quadrilateral is shown. You want to dilate by 3/4. Okay, so you're going to take -6 and multiply it by 3/4, and you should end up with -6 times 3 is 18, -18/4, which is 9/2, negative. So this is -9/2. And then -4 times 3, this is just going to -3. 2 times 3 is 6, so this is going to be 6/4, and that can simplify to 3/2. So right here we've got 3/2, and that stays at 0. 4 we already did, so this is going to become 3 and -3. And I apologize, this is going to be -3 and -8 times 3/4. 8 times 3 is 24, so that's -24/4, which is -6. So those are my new coordinates, and I can graph them. -9/2 is just 9 divided by 2 is 4.5. So 4.5 is here, and -3 is here. So there's P prime. 3/2 is 1.5, so that's here, and 0, which is here. And then the next one is at -3 and 3, -3 here, and -3, -6 is here. So that's my new shape. And then I want to show algebraically if I work backwards. So if I know that from here to here, from P to P prime, you take P prime and multiply it by 3/4. If I want to go the other way, if I want to go from P prime to P, you just multiply by 4/3. And you can prove that by taking the coordinates and multiplying the new coordinates. So -9/2, multiply it by 4/3. And I'm going to do -3, which is the y coordinate, and multiply it by 4/3. And what I should end up with, 9 times 4 is 36. So this is -36/6, which ends up at -6, which is right here. And 3 times 4, well, that's -12. Divided by 3, well, that's -4, and that's right here. So to go from big to little, to go this direction, you multiply by 3/4, and then to go back in this direction, you multiply by 4/3. Next. This coordinate grid is really just here for show if you need it, but the key word at this point is midpoint. And so I know the midpoint formula, you take your x coordinates, divide by 2, and you take your y coordinates, and divide by 2. So this is 5/2, which is essentially 2.5, and this is -4. So my midpoint would be at 2.5, -4. And again, 2.5 is just right here in the middle. 1, 2, 3, 4. So if I drew the line, that would be where the middle is. And that's to get you thinking, because a midpoint cuts the distance in half. So if I wanted to find the halfway point, like I do in this problem, from A to B, you can eyeball it, but if you want to find the exact halfway point, first you need the coordinates, right? So this is at -2, -3. and this one's at 1, 3. And you do the exact same thing. So to find the midpoint, you just do -2 plus 1 divided by 2, and -3 plus 3 divided by 2. Well, this is 0, and this is 1/2. So, -1/2, excuse me. So it's going to be right here. And I'm going to label this point E. And that says to do the same thing from points B to C. So here's at 4, 0. It's going to be somewhere around here, I'm thinking. Let's test it out. So this would be 1 plus 4 divided by 2, and 3 plus 0 divided by 2. Well, this is 5/2, which is 2.5, excuse me. And this is 3/2, which is 1.5. And sure enough, that's where we ended up. And I'm going to call this point F. I can connect these, and I've got 2 overlapping triangles. All right, number 5. Again, I hope you have worked these problems out already and you're not just copying the answers down. Because if you're doing that, you're really not learning anything. You definitely want to try to do what you can first. A lot of this is repeat of what we've learned in the past. Make sure you can do it first and then come back and check your answers with the video. All right, do you agree or disagree that these two triangles are similar? And we want to use side, side, side to prove it, okay? So first of all, let's go ahead and describe the transformation. Well, I can see that one's small and one's big, so I know this transformation is going to be a dilation, right? And this symbol here means similar, so I need to know the distance of the sides so I can calculate to see if they are in fact similar. And so the first thing I'm going to do is I'm going to label this 2, 2. This side, I believe that's 6 and 6. So this one would be 2 squared plus 2 squared, which equals 4 plus 4. So 4 plus 4, this is the square root of 8. And then this is 6 squared plus 6 squared, which is like 36 plus 36. 36 times 2. 2 times 7, 72. So this is the square root of 72. Now right off the bat, I can see that. All right, so this was 2, but 2 times 3 is 6. I'm sorry, I was having a moment. This is 2. All right, so this is 2 squared plus 1 squared, which is the square root of 5. And over here we've got 6 squared plus 3 squared. That's 36 plus 9, which is 45. From B to C, this is 4. This is 1, and this one's 12 and 3. So 4 squared plus 1 squared, that's 9. That's 17. And 12 squared plus 3 squared, that's 144 plus 9. It's 153. All right, so the extended proportion is that, well, what you can see is that this is going to be small, medium, and large. This is the small side, medium side, and large side. So square root of 5 over 45 should equal the square root of 8 over the square root of 72, which should equal the square root of 17 over the square root of 153. And if all these do equal, then you should have side, side, side. Okay, number 6. It says ABC has these angles, so you want to find the measure of the third angle. Well, we know they all add up to 180 degrees. So you do 68 plus 32, and that should be 100. So it's 180 minus 100, which gives me 80 degrees, right? Now if I have a second triangle, and it has 68 and 80, well then, and this one has 68 and 80, then I know the third angle is going to be 32. And that's just because you could do congruent parts of similar triangles are congruent in this case because they're angles. So you could use that as your example, or you could say AA, because if two angles are congruent, then all angles are congruent. So either of those could be good justifications for why you know those two triangles are similar. Okay, here we go. Number 7. We're almost done, actually. So we know that these two, BC and ED, okay, they're parallel to each other. So that means that this angle is congruent to this angle. That also means that this angle is congruent to this angle, because of alternate interior angles are congruent. We also know that the angles in the middle are congruent because of vertical angles theorem. So the congruence statement would be angle, angle, and you could say that BCA is congruent to triangle B matches with D, C matches with E, and A matches with A. Number 8, if the two triangles are congruent, similar, both, or neither. So the first thing we got to do is we're going to use side, side, side. And we know side lengths are proportional in this case. They are similar, proportional. I'm sorry, they're not congruent, they're proportional. So I'm going to do small, medium, large. So this would be 10 over 20. Does that equal 15 over 25? And does that equal 21 over 35? And I'm going to say the answer is no. Because 10 over 20 I know is 1/2. So they're not going to be proportional. So they are not similar. You do have to justify your reasoning with a complete sentence. Cool. All right, moving on. Number 9. This looks complicated, but really it's not. So SR is the long length. So it's actually 16, because 4 plus 12. And ST is the long length, which is really 20, because it's 5 plus 15. So you're going to do SQ plus QT. So this is 4 plus 12 over 4. So it's 16 over 4. And this would be 5 plus 15 over 5, which is 20 over 5. And both of them equal 4. So SR and ST are similar to the corresponding side lengths of the small triangle, or you could say proportional. To the corresponding side lengths of the small triangle SPQ. And then you would say angle S is congruent to angle S by the reflexive property. Therefore, triangle SPQ is similar to triangle SRT by the SAS similarity theorem. And then it says you want to prove that FHG by the SS theorem. So you're going to have a series of side lengths that you're going to have to prove are proportional. And you just had to fill in the blanks for this one.